By now you've completed your study guide in preparation for the gas law test. So this is just a quick run through of the study guide. For the definitions, here are the key points. The definition of temperature is the average kinetic energy. This is always expressed in Kelvin for gases. Absolute zero is the lowest possible temperature where no molecular motion occurs. This is also 0 Kelvin. Pressure is force per unit area. The ideal gas constant is used in the ideal gas law, and there are two possible values that we use primarily. 0.0821 atmosphere liter per mole Kelvin, or 62.4 millimeters of mercury liter per mole Kelvin, the difference being the unit of pressure. And finally, STP. These are the standard temperature and pressure values. Temperature is 273 Kelvin, pressure is either 760 millimeters of mercury or 1 atmosphere. In converting from millimeters of mercury to atmosphere, you divide by the standard of 760 millimeters of mercury to convert to atmosphere. Torr and millimeters of mercury are the same thing, so there's no change in the number, only a change in the unit. To convert from degrees Celsius to Kelvin, you simply add 273. In this review of significant digits, A through H asks how many significant digits are there? Remember, digits such as 1 through 9 are always significant, as in the first example, and the 3 here in example B. Only if there is a decimal would any zeros to the right of the last number be significant, as in G. Because there's a decimal, the zeros to the right of the 5 are significant. Leading zeros are never significant, and trailing zeros are always significant if there's a decimal. In doing calculations, the final answer is expressed to the least number of significant digits of the data when multiplying and dividing, but to the least number of decimal places when adding or subtracting. The rules are different. This diagram demonstrates 3 different instruments that have been created to measure pressure: the barometer, the manometer, and the eudiometer. Thermometers measure temperature. You can read this bold statement that says, the height in millimeters of mercury within the glass tube is the pressure reading. Therefore, if the height of mercury is 688 millimeters, then the pressure is 688 millimeters of mercury. It's really that simple. The combined gas law is the combination of Boyle's law, Charles' law, and Gay-Lussac's law. Each of these describes a different relationship. Gay-Lussac's is the direct relationship between pressure and temperature. Charles' law is the direct relationship between volume and temperature. And Boyle's law is the inverse relationship between volume and pressure. When looking at the graph of an ideal gas, we see a horizontal line. Straight lines represent direct relationships, and curved lines inverse relationships. This graph is practice reading graphs. As you can imagine, this graph will be on the test, and you'll be asked similar questions about reading the data from the graph. Take your time and perhaps even zoom in to find the data points where they intersect in order to answer the questions correctly. This chart was provided once before to give you an opportunity to organize your thoughts for study. On the study guide, it's another opportunity for you to organize your thoughts, to make certain that you know what the relationship is for each of the laws that make up the combined gas law, to remember some of the examples of the demos, to make sure that you know the values of STP, and so forth. Now let's run through each of the calculations. Of course, you'll always want to start with the given information, because that will tell you what you have as far as pressure or volume or temperature. If you're unsure, refer to the units. If it's given in atmosphere or millimeters of mercury, that would be a pressure. If it's given in milliliters or liters, that would be a volume. Because in this problem we're only dealing with pressure and volume, it would have to be Boyle's law. Solving for P2, the new pressure. Rearranging the equation involves simple algebra. When you substitute into the equation, you should always show your work with the units. Your final answer should be expressed to the number of significant digits that matches the least number of significant digits from the original data from the original question. Never use constants or conversions to establish the number of significant digits. The name of the law and the relationship is the same question that we've answered all along. Following the same format, if you write down the given information, making note of the units, liters would be volume, and Celsius is temperature. All temperatures must be converted to Kelvin for gas laws. Once you know which variables you have, volume and temperature, you should be able to pick out which gas law is involved. Rearrange to solve for the unknown, substitute in with the units, and express your answer to the correct number of significant digits. Again, write down your given, making note of the units, convert to Kelvin, write down the equation, show your work in the equation with units, final answer to the correct number of significant digits with units, and then identify the gas law and state the relationship between the variables. In this example, we find that we're given a temperature, a pressure, and a volume. Then it asks for the conditions at STP. At this point, you have to remember that temperature is 273 Kelvin and pressure is 760 millimeters of mercury, or 1 atmosphere, at STP. The unit that we choose for pressure is dependent on the unit that's already been given. The combined gas law is the entire P1V1 over T1 equals P2V2 over T2. We have 5 pieces of given information. We should be able to substitute in to solve for the 6th variable. Notice that all work is shown with units. Dalton's gas law tells us that the total pressure of a gas is the sum of the partial pressures. The key word there is the sum. We add them together. When the total is given, we simply subtract the other gases to determine the pressure of the remaining gas. And finally, the ideal gas law. You know it's ideal gas law if it states anything about the number of moles of the sample. This is the only gas law we're dealing with that has moles of gas. If you're given moles, volume, and temperature, you should be able to solve for pressure. You have to have the R value memorized. Because this question specifies that it wants pressure expressed in atmosphere, we know to use this value of R, 0.0821 atmosphere liter per mole Kelvin. When we rearrange the equation to solve for pressure, and we substitute in all of the data to the equation, all of the units will cancel except for atmosphere, the remaining unit. Since atmosphere is an appropriate unit for pressure, we must have done something correct. And again, the final answer is expressed to the correct number of significant digits based on the original data, not based on any constants or conversions. Study well, and good luck on your test.